lesson 2. Again, this should be reviewed from Algebra 1, freshman year. Solving systems by using substitution or elimination. Now, we've already talked about graphing, which again is a little more time consuming, and it's also can be highly inaccurate, especially if you're not using straight edges. But anytime you have a fractional y-intercept or something like that, or a slope that's not as nice, then you're going to have trouble getting accurate solutions from graphing. And then the last two are substitution and elimination, also known as linear combinations. So, first off, to determine the number of solutions, if they intersect at one point, then you're going to get a solution of x equals a number and y equals a different, a number. It can be the same number, different number. So you're going to get something like 3, 7, -2, 18, whatever. If they're the same line, when you solve using this method, you're going to get, all the variables go away, and you're going to get true statement. So you're looking for a true statement like 5 equals 5, -1 equals -1. And for no solution, you're going to get a false statement such as 7 equals -3. So that's what you're looking for at the end. You're either looking for just one point, a true statement, or a false statement. So let's go over the method. First off, you solve for the easiest variable. You want to get a letter by itself, like x equals or y equals. Okay? Then you're going to replace or substitute that variable into the other equation. Then you're going to solve the new equation, plug the value from step 3 into the easiest equation, and solve for the other variable. Then write your answers in ordered pair. So just looking at this, you have 2 x's and 2 y's. The top left x has a 3 in front of it, coefficient 3. The top y has a 4 in front of it. The bottom y has a 2 in front of it. And the bottom x on the left has a coefficient of just 1. That's your one you're going to want to solve for. That has the easiest letter because it's already by itself. Now, sometimes you can divide by number and get the x or y by itself, and that's fine. But you want to go for the easiest one. This one's easy because it's already by itself. So to rewrite it by itself, I'm going to subtract 2y and move it over like this. Now you have a choice. You could also write x equals -2y plus 2. It makes no difference. Okay? Now, what you're going to do is you're going to take this and substitute it in for x right there. And I highly suggest, unless you're really good at this, you do exactly this. You circle it and draw an arrow saying, this is where I'm going to put it. And you're literally just taking the x out and putting 2 minus 2y in parentheses. Now, you're going to distribute your 3 and get 6 minus 6y plus the 4y equals -4. You're going to join like terms. And if you want to join like terms first, or move the number over here and move the number over first, and join like terms at the same time. If you need to do it in baby steps, you can. Then you solve, and you get y equals 5. Now, once you have y equals 5, you can plug it in to either of the top 2 equations. The easiest one is going to be the first one, because x is by itself. You're not going to divide by anything. Now, if you put the 5 in right here, it's not a big deal. You'd end up with 3x plus 20 equals -4. You'd subtract 20 and divide by 3. You're going to get the same answer. It's just going to be a little bit more work to get x is -8. Now that you have both x and y, you're finished. And that is substitution. So we're going to do that for this one. Right now we're going to do a couple practice problems. So looking at example 2, our easiest one is going to be, I believe, right here. Now, it's not ready yet because the x does have a -1 in front of it. So we're going to divide everything by -1 and get x minus 3y equals -1. That should be a y. Now we need to get x by itself. So we're going to move the 3y over by addition. So that gives me x equals positive 3y minus 1. I personally just like to put the variable in front, but it's up to you. So this is going to go right here. So I write 4, don't forget parentheses, 3y minus 1 plus 6y equals 8. Notice I have nothing but y's now. I'm going to distribute my 4 and get 12y minus 4, careful that you distribute the 4 to both, plus 6y equals 8. I'm going to combine my terms. That's going to be 8, and I'm going to do it in baby steps here. That's going to be 18y minus 4 equals 8. I'm going to add 4 to both sides. And then divide by 18. Y equals 12 over 18, which is going to reduce to divide by 3. No, divide by 6, sorry. Wasn't thinking. Divide by 6, that's going to give me 2/3. Now you may be worried because, oh, why is 2/3? But it's really not that big of a deal because notice that both of my y coefficients are multiples of 3. Now, which one's easiest? I'm going to pick the first one again because x just has a -1 in front of it as opposed to a 4. So I'm going to plug that back in. I'm going to do negative x plus 3 times 2/3 equals 1. Followed by 3 is going to cancel. That's going to give me negative x plus 2 equals 1. Subtract 2. And then divide by -1. X is 1. So my point of intersection is 1, 2/3. And that's my solution. Okay, example 3 is easy because C is already by itself. So I'm going to plug it in right here, and this is a quick and easy one. So -2, don't forget my parentheses, 3d plus 2 plus 6d. Again, I have all the same letter now. I'm good to go. I'm going to distribute my -2. So -6d minus 4 plus 6d equals -4. Well, look what happens here. -6d plus 6d cancels. I get -4 equals -4. That is a true statement. And that means I have infinite answers, also known as all real numbers. In other words, no matter what I plug in, the symbol for that is a big capital R like that. No matter what pair I put in, I will get a true statement because these lines are the same lines. All right, the elimination method. So, put the equation in the standard form, okay, which is example 4. You can see they already are. Then you're going to multiply one or both equations by a constant so that coefficients differ only in sign. So x's or y's doesn't matter, but you want one positive, one negative, like a +5 and a -5. Then you're going to add them together, which will eliminate either the x or y. Then we're back to the other problem. Solve the remaining variable, substitute back in, write your ordered pair. So, example 4. I have a choice here. Now I'm going to show you both actually. Because These are both easily adjustable. If I multiply this by negative 3, I will have negative 3x minus 6y equals negative 6. Now I'm just going to bring this down underneath it. 3x plus 4y equals negative 4. Notice I have a positive 3x and a negative 3x. When if I add these together, they cancel, they eliminate, disappear. Now I get negative 2y equals negative 10. Divide by negative 2, y is positive 5. Now I'm going to plug it into the second one because x is by itself. So 2 times 5 equals 2. Yes, it is a 5. I'll clean it up. So x plus 10 equals 2, minus 10, x equals negative 8. So my point of intersection is negative 8, positive 5. But notice, 2 also goes into 4. So I could have multiplied this by negative 2. So it would have given me negative 2x minus 4y equals negative 4. If I bring the first one down, 3x plus 4y equals negative 4. Now I do addition. 3x minus 2x is easily just x. These cancel, and I get negative 8. Ta-da! If I plug negative 8, I'm going to save time here. If I plug negative 8 in, well, I'll do it. I'm going to plug in the second one because x is by itself. So negative 8 plus 2y equals 2. Add 8 to both sides. 2y equals 10. Divide by 2, y is 5, and I get the exact same point of intersection. Now, here's a hint. Sometimes you'll get a nasty answer, like when you're doing this the first time, and you get a nasty fraction that will not go into the original equation nicely, and you have nasty fractions to work with. This is a nice method. Go back and just eliminate the other variable and just do elimination twice, and you won't have to worry about the nasty fractions. Okay, so let's do this real quickly. A couple examples here. First off, we want to get a's and b's on one side. So on this one I've already got my a's and b's here. But here I need to move my a over. So I'm going to have negative 5a plus 5b, and make sure they're lined up, equals 15. Now, this is one where there's no way to make 2 become negative 5 or make 3 become negative 5. I mean positive 5. There's no way. So what you have to do here is multiply both and choose which one you want to eliminate. You want to get the a or the b. Now, since a already has a positive and negative, I'm going to go there. But it really makes no difference since you're multiplying. So what's the first number 2 and 5 go into? It's 10. So if I multiply this by 5 and this by 2, I'll get 10 and negative 10. Again, this should all be reviewed for you. So 5 times 2 is 10. 5 times 3 is, a. 5 times 3 is 15. And 5 times negative 1 is negative 5. 2 times negative 5 is negative 10, a, plus 10b equals 30. I'm ready to add. My a's cancel. I get 25b equals 30 minus 5 is 25. So b is 1. Now, I can go back to either of these to plug one in. I can plug it in here or here. It really makes no difference. They're pretty much equally easy. So I'm going to plug it in to the top one. 2a, whoops, that's a big A, plus 3 times 1, I'm just going to write 3, equals negative 1. Subtract 3, I get 2a equals negative 4, divide by 2, a equals negative 2. So we always go in alphabetical order if we don't have x and y. So I have negative 2, comma 1, and that's my solution. nasty, well, not nasty, we have some fractions here. So I can do whatever I want. I can cancel my y's or my x's. But looking ahead, I'm going to say, hey, wait a minute. If I multiply this by 9, that's going to cancel my x's, and it will get rid of the 3's in the denominator. Now, some of you might want to take baby steps. Some of you might want to multiply the bottom by 3 first. Get rid of the denominators, and then do the next step to figure out what you want to cancel. That's a perfectly legit way of doing it. That's okay. So, I'm going to distribute my 9 and get negative 9x. 1/3 of 9 is 3, so it's going to give me 3y. You got to be careful here. I'm going to get a negative. 3 and 9 cancel, but then I got to multiply by this 7 here. So that's going to be negative 21. Another way to do it is 9 times 7 is 63. And divide by negative 3 to get negative 21. It's however you want to work it. Bring the 9x down. And I'm good to go. My x's cancel. Oops, look what happens here. My y's cancel. I end up with 0 equals negative 6. That is a false statement. That means that these will never intersect because they are parallel. So there is no solution. Okay? Now, real quickly, if you want, like I said, if you wanted to multiply the bottom one by 3, just to get rid of those 3's, you'd end up with negative 3x plus y equals negative 7. Okay? And you would have had this problem. And that's a perfectly okay way of doing it. Now, at this point, you say, well, if I multiply by 3, the x's will cancel. Oh, wait, so will the y's. And you're going to end up with this. Negative 9x plus 3y equals negative 21. Look familiar? It's the same thing. And so you're going to end up with the same answer. But I just want to point out that there's a couple different ways of dealing with those fractions. But now you're good to go.